Welcome to CS3308 Information Retrieval. This is the Unit 2 lecture part 3. During this lecture, we're going to talk about this subject of tolerant retrieval. Another way of thinking about this is wildcard searches. And how we do that and the need to be able to do that and some of the ways that we do that. So, what is a wildcard query? Well, and we've been talking about this a little bit, but the whole idea behind a wildcard query is the ability to have a portion of a term that I'm searching for because I don't necessarily know exactly the term. So maybe I'm using the beginning of the word, or maybe want to use the end of the word, or maybe there's a point in the middle where I just don't understand what it is. So it really gets down to this idea of wildcard queries and how do I implement that? Now we know, because we just talked about this in the previous lecture, we know that we can't do this with hashing. So if I'm using hash as a data structure, I'm not going to be able to do any kind of wildcard queries. However, we do know that when I'm using trees, it does become a possibility. So how would we implement that? So before we get into that, we'll kind of look at this whole idea of query processing. And essentially what happens in the query is I'm going to go through that data dictionary. I'm going to try to find everything that matches the term that I have, right? So, if I'm using a term that's an entire word, it might be relatively easy. So maybe if I'm looking for the term home, all I have to do is I have to go look up in the dictionary to find the word home. But there might be other things related to home, maybe home mortgages or home financing or home other things. So perhaps if I used a home star, it's going to capture everything with the prefix of home and anything that goes on behind it, right? Now, what happens in this case is that I might have multiple different kinds of Boolean queries that would have to be executed in order to retrieve this kind of a result. A great example when we look up here at these examples up here is where I have, I'm putting that wildcard in the middle. And essentially what's oftentimes going to have to happen here to process this query, I'm going to have to first of all search for this. So I'm going to have to look for something that begins with SE, okay? And then I might have to go back in and search for something that ends with ATE. Okay, so now I got two different queries, and then I'm going to have to intersect the two. So I'm going to have to look for where those two things are actually the same row in order to fulfill this portion of the query. The same thing kind of goes for this particular example here. So again, some complexity in that processing. Now, we talked about the fact that trees, and in particular bee trees, really good at handling things where I have a wildcard at the end. So I can put that wildcard at the end. It's relatively simple to do it. The problem is again, how do I deal with these ones where I'm putting the wildcard in the middle? And this is where this kind of becomes difficult. Now, one of the ways to address this kind of a problem is through the use of what we're going to call a permuterm index. And we're going to look at just a moment what that means. So the idea behind a permuterm index is the idea that I might take a term that has these kinds of potentials in the middle and create a whole bunch of specialized copies of it. Right. So in the permuterm, if I wanted to use to search for the word hello, I might want to put that into the term exactly as that is. In fact, I might want to end it with this special character that basically says hello beginning with anything, and anything after that is going to get returned. Okay. The problem is what do I do in the middle? And essentially what happens with the permuterm is that you can see that essentially we are shifting the letters, okay, and then searching on the remainder of it. And so this is a unique way of doing it. And basically what allows us to do is put these terms in here in this form. And that allows us to execute a variety of different kinds of searches, right? So for example, it allows us to execute the search where I have some prefix with an ending on it. And essentially what I'm going to do is I'm going to look up the ending that is at the end. Okay. Now, one of the disadvantages, and perhaps you're looking at this thing saying, well, gosh, I had a very simple word that has 1, 2, 3, 4, 5 letters, and what I wound up producing out of that is 1, 2, 3, 4, 5 different terms. And you are correct. this permit term index, one of the disadvantages to it is that it absolutely explodes the number of terms that I wind up having in the dictionary. So essentially what we're doing in it is I basically rotate the query wildcard to the right, and I'm doing this over and over and over again, and I'm storing those results right in the dictionary. That's going to become part of the B tree. And what this does is it typically quadruples the size of the index, so the number of terms that are in that. So yes, it allows us to do the wildcard searches, but it has the disadvantage in that it's going to really use a lot more space. There's another approach to doing this, which is kind of this whole concept of a bigram index. And what the bigram index does is it kind of takes terms and it splits them into smaller chunks, smaller pieces, right? So essentially what you wind up doing is you have a second index that has just the bigrams, and then that second index will allow you to find the primary terms which exist in the first inverted index. So basically you have two of them. One of them basically allows you to search to find the term that might be associated with these different wildcard terms. And then the second one actually goes to find the specific document. So it's a little bit different way of doing it. This kind of gives you an example of what it is. So if I had in my byword index the $M, it might map to all of these terms, and if then I return these terms, and I use these terms based upon this query value to actually search the index. So it's kind of a little bit different because it's doing it in two different steps. And we're just going to go a little more detail here on how we actually do that. So again, in the byword index, I might be taking this and splitting it up into the pieces, looking for these two-letter symbols that can be built from it, such as $M, MO, ON. And again, each of these would then be used because we're looking at the query term that I put in there, MON star, and I'm saying, okay, how do I break that up into these two-letter terms, or the byword index terms? And essentially, I come up with these three, right? $M, MO, ON, and then essentially I go into the inverted index that has the by terms, and find out what this points to in terms of actual terms, what this one points to, and what this points to, and all three of them are then combined, and that's what drives what the selection criteria is out of the inverted index. So just a real quick couple of summarizations on this in terms of processing of these wildcard queries. Two different approaches to do it. Obviously the first one is through this whole shifting of the values using a permaterm approach, right, which is going to dramatically increase the size of my index. The other one is this concept of using the bigrams in a bigram index, and essentially what that does is it takes all of these breakups of two-letter terms that then point to specific terms through the use of two different inverted indexes, and then that allows me to get to the actual terms that I'm going to retrieve.